Alright everybody, I'm going to give you some notes over section 6.6. This is dealing with properties of kites and trapezoids. I may be talking a little bit fast, so feel free to obviously pause this if I'm going too fast, or go back or listen to it again, do what you got to do there. We're talking about kites and trapezoids. Now, what makes a kite is the fact that we have two pairs of consecutive congruent sides. For example, here we have a kite A, B, C, D. These are consecutive sides, A, B, and AD. Those are consecutive sides, those are congruent. And then B, C, and CD are consecutive sides. So notice that they're not opposite sides, they're consecutive sides. All right, there are two distinct pair of consecutive congruent sides. That's what a kite is. Now, we've got some properties of kites. Obviously, we always have properties for all these things. So if a quadrilateral is a kite, then its diagonals are perpendicular. So the diagonals of a kite are perpendicular. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. That's the second one here. And notice here that the angles that are opposite here, which are between the non-congruent sides. Okay, so these are the ones that are congruent, not necessarily these two. These are not congruent angles here. All right, it's the side or the angles that are opposite, that are facing each other, that are formed by the non-consecutive angles. Those are the ones that are congruent. So, if Lucy is framing a kite with wooden dowels, who hasn't done that in their life? She uses two dowels. One measures 18 centimeters. So this side is 18, this side is 18. One dowel that measures 30 centimeters, and two dowels that measure 27 centimeters. So here are these 27 centimeter and the 30 centimeters this side J. Now, to complete the kite, she needs a dowel to place along KL, so she needs this side replaced right here. She has a dowel that is 36 centimeters long. About how much wood will she have left over after cutting the last dowel? So what we need to figure out is how far is it from K to L. Well, what we know based on these properties is we know that this angle is a right angle. Diagonals meet at right angles. What we also know is if we've got this dowel is 30, that means actually this side is 15 and this side is also 15. So what I'm going to find is the measure of KN, and then I'm going to find the measure of NL. And if you notice, we have right triangles. So I'm going to use the Pythagorean theorem. I'll label this as X and this is Y. So in order to do so, for X, I'm going to take X squared plus 15 squared equals 18 squared. That gives me X squared plus 225 equals 324. So in subtracting here, I get that X squared equals 324 minus 225 will be 99, making X equal the square root of 99. So that's X. In fact, I could even find that value. That would be about 10.9. So X is 10.9 centimeters. Now, to find the measure of NL, let me change colors here. To find NL, I would say that 15 squared plus Y squared equals 27 squared. I'm going to subtract that 15 squared from 27 squared, and that's going to find, and then I would take the square root of that, and that would find Y. Now I'm going to be quite honest here, people. I don't have a calculator. Hopefully you do. If you do, take 27 squared and subtract 15 squared, and then take the square root of that number. Okay? Add the X and the Y then, and that finds the measure of KL. Okay? Actually, I'm going to skip over that. So if we have a kite ABCD, the measure of angle DAB, this angle is 54 degrees. We know that the measure of CDF is 52 degrees. We're to find the measure of BCD. Okay. Well, there are several things we can do here. First of all, if this is 52 degrees, we know that this is a right angle. So this angle right here, angle FCD, would have to be whatever, if we take 90, add it to 52, that's 142. I'm going to take 180 minus 42 degrees. Or I'm sorry, 142 degrees, sorry about that. And that would give me 38 degrees. So this angle right here is 38 degrees. Now that means we can actually conclude that this angle right here, BCF, is also 38 degrees. So, since we know that, then we can add these two together, and the measure of angle BCD is 76 degrees. Now for the measure of angle ABC, then what we could do is, first of all, this angle right here, that does cut this angle in half. So this is 27 degrees, this is 90 degrees, which leaves for this angle in here, let's see, that would be 53 degrees. Well, that's 53 degrees, this is 52 degrees, because these two angles would be congruent. Then the measure of angle ABC would be that 53 plus 52, which is 105 degrees. So the measure of angle ABC, easy as 1, 2, 3, is 105 degrees. Now, for the measure of FDA, let's see, F is right here, FDA would also be 53 degrees. So we say the measure of angle FDA is 53 degrees. So those were kites. Trapezoids. You've studied trapezoids before. One of my favorite shapes, I just like the name, is quadrilateral with exactly, no more, no less, one pair of parallel sides. Each of the parallel sides is called a base. All right, so you actually have two bases here. This is one, this is two. The non-parallel sides are called the legs. So the parallel sides are called the bases. The non-parallel sides are called the legs. The base angles of a trapezoid are the consecutive angles whose common side is a base. We can say these are base angles and these are base angles. They kind of relate to each other. If the legs of the trapezoid are congruent, then you've seen this phrase before, isosceles. An isosceles triangle is one where you have two congruent sides, while an isosceles trapezoid is, again, one with two congruent sides. All right? We've got some theorems, here we go again, that have some properties of an isosceles triangle.